Okay, so we're going to review some things about exponents. You've seen it before, but you may not have it in the forefront of your mind. So I have a to the x power that we're going to refer to as we go. A is this bottom part. It is called the base. That is the number that you are multiplying by itself. And then over here, the x is called the exponent. Sometimes people call it a power, but exponent is the mathematically correct term. So let's go down and do zero exponents first. Any non-zero number raised to the zero power is, do you remember?
0.
It's 1. And then 0 power. So 2x to the 0, whatever it is, you're just going to get a 1. And that is because that's what makes the negative and positive powers and everything work with the same rules. So we explored that a lot in 8th grade, if you were with me, which maybe was one of you. Yeah. It's been a hot minute, but we did talk about it. Okay, so now let's go over here to negative exponents. To get rid of a negative exponent, you find the reciprocal of the base. So for example, if I have x to the negative 2, that means it's 1 over x squared. So when they have a negative power, you can think of it as being repeated division instead of multiplication, since it's in that denominator. If the negative exponent is in the denominator, you need to move it to the numerator. So all these fraction terms. So if I have x over y to the negative third, that flips to the top. And then I have x, y to the positive third over 1, or just x, y to the third. And there's another little side note that I'm going to put on here too about fractions. So if I have something like 2/3 to the negative 2 power, what that means is I'm going to flip that fraction, make it 3 over 2 to the ordinary positive 2 power. So then I would square everything. So 3 times 3 is 9, 2 times 2 is 4, and that's what I would get for that one. So a lot of times they don't want you to leave any negative exponents in the answer, even if that's what you got when you used other properties. And so your last step a lot of times is just to get rid of that. Okay, so let's go down to product of powers. So in multiplying two bases that are the same, you add the exponents. So for example, x to the 9th times x to the 6th times x squared, I'm just going to add 9 plus 6 plus 2. So 9 plus 6 is 15 plus 2 is 17. And the reason for that is if I wrote all this out, this is x multiplied by itself 9 times. That would be 6 of them. That would be 2 of them. And if I just wrote it out as a big long thing, if x is being multiplied, there'd be 17. That's why that rule works. Like I said, we've looked at that before. When raising a power to another power, you multiply the exponents. So notice on the example, there's only one base. This had the same base being repeated. This is only one base of x. I'm taking it to the 2nd power, and then I'm taking the whole thing to the 5th. So what I would do is take 2 times 5 and get 10. So that's that rule. Quotient of powers. When dividing two bases that are the same, you subtract the exponents. So if we're multiplying them, you add. If you're dividing them, you subtract. So for example, if I have x to the 5th over x squared, I'm going to take 5 minus 2. I get x to the 3rd. And that has to do with canceling. That one I can show you pretty quick. So if I'm multiplying x by itself 5 times in the numerator and 2 times by itself in the denominator, I can cancel out those, and I'm left with x times x times x, which is x cubed. So it just has to do with how we're canceling things. Does this kind of ring a bell? Do you guys remember some of these? Maybe, kind of, sort of. Okay, so to find the power of a product, you distribute. And I got that out of a textbook, but I don't know if you should actually call it distribute, but it makes sense. the exponent. So what that means is I'm going to take this 3 to the 2, and I'm going to have 2 to the third. I'm going to take this 3 to the 2, and I'm going to have x to the 2 times 3, which I'll make 6 here in a minute. And then I'm going to take it and distribute it to the 5, so I'm going to have y to the 5 times 3. So 2 to the third, if it's a number, they actually want us to work that out. So 2 times 2 is 4, times 2 is 8. And then I will multiply those powers, and I don't know why I did that. I wrote y before x, so x to the 6th and y to the 15th. So I'll just cover that up with my finger for right now. So you distribute that power out, and then you're going to use your power of a power rule with those. And people will forget and just leave it as 2 to the third in the front. They do want you to go ahead and just make that a number. Okay, so to find the power of a quotient, it's kind of the same thing. You distribute the exponent. So when I distribute this out, I'm going to have 5 squared. I'm going to have x to the 4 times 2. I'm going to have 2 squared. And I'm going to have y to just be 1 times 2. So I took a lot of room there to write out the work. That's okay. I'll just have to write small here. So 5 squared is 5 times 5, so that's 25. And I'd have x to the 8th. 2 squared is 2 times 2, which is 4. And then y to the 2nd. And at that point, you would check your fraction and just see if you could cancel anything out, if you could reduce anything. The way this one is set up, you do not have that going on, so we're not going to worry about that right now. And this is the part I just added the other day, so I know exponent got cut off when I copied it, but we have an idea. So if your powers are fractions, then that means you're going to have a root, or possibly a root and a power. So if I have x to the 1/2, that means square root of x. If I have x to the 1/3, that means cube root of x. Then if they start putting a number in the top that's not 1, we will also have a power. So x to the 2/3 means I'm taking the cube root of x, and then I'm going to square it. So the top number becomes a power, and the bottom number becomes your root. So we did this maybe sophomore year? Maybe we did it last year, but I think it was actually the year before. And then, so on this, if I have 27 to the 2/3, that means I'm going to take the cubed root of 27 and then square it. And you used to have to do that in steps, but actually, the thing about our calculators, if it's just a number, we can actually just type it in. So I could actually do 27 to the, go over into my math menu and put in 2/3 as a power. It feels like cheating to me. But you can actually just type it in like that, and it's going to give you 9. But I'll also show you that if I, oh, not that one, oops. If I do the cubed root of 27, you get 3. And then if I square that, I still get 9. So where this is important is when you have x's and manipulation, just so you know that they're the same.